Okay, we are wrapping up the last video in the staircase problem. Last time we were setting up code to handle the combinatorics approach to solving the staircase problem, and where we left off with being able to display the correct step combinations that we would need. So let's just run that one more time. Oops. What did I do? Python step combinatorics. Okay, there we go. And these were the possible step combinations that we obtained. All we need to do now is figure out how to calculate binomial coefficients as well as multinomial coefficients, and I will cover that on my surface. So I'll see you there. Okay, I wanted to start off with a simple example of calculating a binomial coefficient, and the example I wanted to do was 60 choose 3. Now if I just go to the formula, this would end up being 60 factorial over 3 factorial over 57 factorial. Now if I just looked at those factorials individually, they are absolutely insane numbers. So 60 factorial is about 8.321 times 10 to the 81st. 3 factorial is just 6. 57 factorial is about 4.053 times 10 to the 76. So, you know, times 10 to the 81st, times 10 to the 76, those are astronomically large numbers. However, there's a lot of simplification that goes along in there, and we end up getting a quite reasonable number of 34220, 34,220. So let's break this apart a little bit. So I can break off the 60 factorial like so. I could say 60 times 59 times 58, and then I would be left with 57 factorial. Then the bottom, we would still have the 3 factorial, which I'm going to rewrite now as 1 times 2 times 3, and then we would also have the 57 factorial. Anything over itself is just 1, so I'd just be left with 60 times 59 times 58 over 1, 2, 3. Now here what I'm going to do is point out something that it seems a little obvious, but I do want to hit on it. I am going to multiply and divide the numbers in my numerator and denominator in a very specific order. Okay, first I'm going to take 1 times 60. It's the first number in my numerator. I'm going to get a result. Then whatever I get, I'm going to divide that by 1. Okay, then I'm going to multiply by 59. Then I will divide by 2. Next, I'm going to multiply by 58, and finally divide by 3. Now, in each step of this, I'm going to maintain an integer. Okay? So 1 times 60, that's just 60. We'll take that result, 60 divided by 1, that's just 60. 60 times 59 is 3,540. And then here I want to note, okay, I've taken 2 consecutive numbers, the 60 and the 59, okay? Any consecutive 2 numbers has to have a factor of 2. So I know that 3,540, even though that it's even, because it's the multiplication of 2 consecutive numbers, there has to be a factor of 2 there. that would give me 1,770, and then I'm going to multiply that by 58. Again, now this, any three consecutive numbers, the 60, 59, 58, those are three consecutive numbers. It has to now have at least one factor of 3. So when I multiply this number by 58, I get 102,660. And when I divide that by 3, I'm guaranteed that this number here has to have a factor of 3, and I'll get 34,220. And that's going to be our basic approach in calculating binomial coefficients. Now for multinomial coefficients, it's actually quite simple. So let's just do a quick example. I'm going to do 5, 2, 2, 1. And then this would be represented by 5 factorial over 2 factorial, 2 factorial, 1 factorial. This would give me a result of 30. And I can work this out by actually just doing consecutive combinations or just binomial coefficients. So maybe the first thing I would do is say, of 5 objects, just choose, say, 2 of them. Okay? And now, of the 3 remaining, choose another 2 of them. And then, of the 1 remaining, choose 1. Okay? I'm going to expand this out. This is going to be 5 factorial over, that would be 2 factorial, 3 factorial. The second one would be 3 factorial over 2 factorial, 1 factorial. And then the last one would just be 1 factorial over 1 factorial. And then here we have some pretty interesting simplifications. So I have a 1 factorial there, I have a 1 factorial here, I have a 3 factorial here, and 3 factorial there. So all of those simplify out, and I would be left with 5 factorial in the numerator, 2 factorial, 2 factorial, 1 factorial, okay? Which is exactly what we had on top, okay? And then the pattern ends up being something as follows, okay? So if I want to calculate n factorial, k1, k2, all the way up to km, the formula would be as follows. So I would do k1, choose k1, multiplied by k1 plus k2, choose k2, so on and so forth until I would get to k1 plus k2 all the way up to km, choose km. Okay, and then one thing to note here is that n is equal to k1 plus k2 all the way up to km. And this is the formula that we'll end up using to calculate our multinomial coefficients. Okay, back to coding. Okay, so let's start working on calculating these binomial coefficients and multinomial coefficients. We'll first start off with the binomial coefficient, and let's just work it out up here. So def, I'm going to call it binomial coefficient, and we'll be passing it an n and an r. An n for the total number of things that we're choosing from, and r, the thing that we'll actually be choosing. Now here's the one thing to consider about binomial coefficients. They're symmetric in the sense that there's kind of 2 parts in that denominator. And so what we want to do is if if n minus r, if that is less than r, then what we want to do is set r equal to n minus r. Okay, that will make calculations a little bit easier on the computer. Not necessarily entirely necessary, but good to check. Now let's set up the result that will actually end if. That's better. Now what we want to do is set up the result that we want to return. I always like using just result. So result, I'm going to set it equal to 1 at first. And what I'm going to do now is for I in range, and I'm going to go from 0 all the way up to r. Okay. Now remember, in this range, it's not going to actually, I is never actually going to hit r. It's going to be 1 less than that. Okay. And so what our algorithm was to take our result, which is 1 now, and I want to multiply it by, well, I'm going to set it equal to result times, and I'm going to do n minus I. Okay, so it's going to start at the highest value of n, and then each time this runs through, it's going to reduce it by I. Okay, then after that, I'm going to take my result, set it to whatever my result currently is, but divide it by, where's divide? And here I'm going to do 1 and then plus I. Okay? And then after that, I'm just going to return our result. Okay, so that should work. I'm just going to copy that so I don't have to worry about spelling it. I'm going to head and comment that out just momentarily while we check that our coefficients, our binomial coefficients, are working. And I'm going to use the example that we did on the surface. So 60 choose 3, and we will print that out. Okay, let's see if that works. We should be expecting 34,220. That's great. One thing that I do want to note here is, so remember how I said binomial coefficients are kind of symmetric? So 60 minus 3 is 57. So if I were to input this now, we should get the same result. Good. And then 60 choose 60. Anything choose it itself should be 1. Good. And then 0 choose 0 should be 1 with how we set it up. Remember that I set our result always equal to 0, and then how Python deals with zeros. This would never end up running, so our result would just return as 1. Okay, so we'll define our multinomial coefficient. And here we're eventually going to be sending it our step combination, so we'll just call it that for the input. And again, we'll set a default result to 1. And I'm only going to run this if the elements in our step combination list is more than 1. If it's just 1 element, then it'll just be a result of 1. So that should be fine. So if our step combination, the length of that is greater than 1, we will do work. Otherwise, we will not. Now here, what I'm going to do is I'm going to set a running sort of n for the base of the combination, and we'll set it equal to 0. Okay? Now, for I in step combination, I will set n equal to n plus I. And now I'm going to set our result equal to whatever our result currently is times, and then we'll call the binomial coefficient. And we'll send it n comma I. Okay? And then once everything's said and done, we will return our result. Okay. And then we want this to be our multinomial coefficient. And then here, let's use the same example that I did on my surface. So that would have been 2, 2, 1. And then remember, or recall, or note that 2 plus 2 plus 1 is 5. Okay? And then here we're looking for a result of 30. Good. Okay. And so now we are almost done here. So remember, the reason that we are doing these step combinations, the binomial coefficient, multinomial coefficient, was we're wanting to sum up the results of the valid step combinations that we obtained. Okay. So right here, let's set up a result. So this is the result of the number of ways of climbing our stairs. And here we'll be setting it equal to 0. And here we'll say, let's put the result equal to whatever our current result is, plus our multinomial coefficient, and we'll be passing it our step combination. Okay, we no longer need this down here. I'll uncomment this out. Now this is the example that we did in the last video, and recall that it should give us 13 ways. So cross your fingers that we get 13 ways. Oh, it's not going to give us that because we need to return it. So return result. Oh my god. What was that? Okay, so this should work now. Oh no, I didn't print it. Should work now. 13. Yay. Okay, now I do want to note that this algorithm runs faster than the recursive algorithm, but it doesn't work faster than the kind of Fibonacci way, the backwards lookup. However, this still does quite well if I did 1,000, and I'm just going to do step options of 1 and 2. Still gives me a result. Takes a moment, but still I'm pretty snappy there. Still, again, quite a large number. Did it quite fast. If you recall, the recursive algorithm gave us a lot of difficulty with just, I think, the staircase length of like 30 or 40. However, this algorithm does not work nearly as well as the Fibonacci way or the backwards lookup. Anyways, that concludes my series on the staircase problem. Thanks for joining me, and I hope you'll join me again. Bye.